Good day, everybody, and thank you for coming to this webinar. My name is Sean Martin, and I am the CTO at Cambridge Semantics, a data integration company out of Boston, actually. Even though we're called Cambridge Semantics, we never actually managed to get across the river to Cambridge. What I'm going to talk about today is a bit of an adventure that I've been on, working to take what we've been doing with our sort of mainstream product, which is an enterprise data integration product based around knowledge graphs, and discuss how we have been using generative AI to put a natural language questioning type application solution on top of that, and talk a little bit about the lessons that we've learned, where we are currently, and what is going to be next. I'd encourage everybody to ask their questions as they go, so that we've got a good store of them when I'm finished my presentation, and we can get into more of an interactive discussion. So hopefully everybody can see the full slide, and the windows over the top are not getting in the way. So the first thing I just wanted to introduce very briefly is the knowledge graph environment that I'm working with, just kind of so everybody has a grounding of what the back end is that I am going to be building the front end or the conversational BI system on top of. We as a company sell a product. I don't really want to discuss it too much, but really the idea is to create a knowledge graph as a kind of a data fabric which integrates both structured and unstructured data. So it's pretty different to a siloed way of integrating data, where you end up with lots of sort of silos that are separately talked to. Instead, we create a cohesive layer that we describe using an ontology. Everything's based on standards, semantic web standards. So we have our ontologies describing the data, and as you'll hear, this becomes very important in a little bit later. So the product itself we call Anzo. So if I say Anzo, you'll know it's the back-end product that actually is the knowledge graph. Anzo is built to bring in data from many different sources, turn them into graphs, and then knit them into a coherent graph against which you can build data products, which are really query-based views into that data. And on the right-hand side, you see we have all sorts of accessor methods, BI tools, queries, and so on. But the most important one is the generative LLM, generative AI-based client that we've been building for the last, I don't know, maybe about a year now. Standing back a level from our product and just talking instead about knowledge graphs in general, and why they're very good to use for data integrations, because you can simplify complicated data. And all the work of what I've been doing for 15, 20 years now, both in the current company and when I was with IBM, is about how to create harmonized views of data that is described using ontologies that describe the data in the language of the consumers of the data. So we want to be able to bring lots of data sources together, and we want to be able to describe that data so that end users will recognize it, and the relationships between different sort of types of things we're describing. And of course, the problems to overcome there are lack of all the software needed to do it, and the lack of scale in the kind of databases we need. I'm pleased to say that those problems are behind us, which allows us then to start to build the kinds of applications we're going to discuss today. On the right-hand side of the slide, you'll see what looks like a complicated graph. That's actually a model, right? That's not the instance data, that's the model. Each circle represents an entity within the graph, and the different colors represent different sources of data. In this case, it's moderately complicated because there's a lot of unstructured data that tends to be entity rich. And as you'll see, this kind of representation becomes key a bit later on, when we want to allow end users to interact directly with this data and simply ask questions of it. Let's just discuss very briefly. I think most of people who are on this call who will have been looking into this for a little bit will understand these immediate issues with LLMs in enterprise, and we're still suffering from this. All of our customers at Cambridge Semantics are very large organizations, and a good number of them are not able to use the OpenAI or zero flavors of the OpenAI APIs yet, because it simply are banned within their organizations. And I guess there's a whole lot of learning going on, but the problems on the left here are ones that are getting in the way of these organizations wanting to use this very powerful technology for solutions. And on the right-hand side, you understand what the desire for that an enterprise, or even the requirement an enterprise organization has, and on the left, the perceived issues or the actual issues with the LLMs. One issue is they're trained on public data, but of course, our customers want to answer questions about their own data. Pretty obvious, but they don't want to put that data into LLMs for general consumption for obvious reasons. So they have their own IP and trade secrets and so on. So they want to make sure that the data that they access is not shared with the world. The second issue is that many of them are in highly regulated environments, and even if they weren't, they're not sure they can take the risk of getting answers that are just partially right or sometimes completely inaccurate. I often use, and if you've heard me talk before, I often use the example of when I asked ChatGPT who founded Cambridge Semantics. It usually gets me, but there are quite a few people who founded the company, and it often doesn't get many of them. And then it also gets 2 or 3 other people who I've never heard of or may not even exist. So when enterprises see that and they experiment, they simply throw up their hands because they can't live in an environment where a good chunk of the answers to their questions may simply be hallucinated. They also need to, particularly in regulated environments like pharmaceutical businesses, but others too, financial services, they need to understand exactly where the answers came from. So they need to have pointers back to the source materials that's kind of a chain of custody for data. So data provenance is absolutely essential. And if there isn't a way to do that, then they can't use these systems. Let's see, another one that's sort of out there is the unsettled sort of business of who actually owns the answers, given the amount of training data that has been used sort of without permission. And I know that's sort of working its way through beginning to work its way through the court systems. But if you're an enterprise, it's pretty risky to build your solution, which could be pretty expensive and maybe become something you depend upon. It's pretty risky to build on something where you're not quite sure if someone's going to come after you and say, well, hang on, those answers they actually belong to me. So all of these are issues that our customers have. Some are willing to live with them and others are not. And the solutions that I've been trying to work around are ones that address these problems directly and provide mechanisms that will work both for a customer, but also work with what is currently available in terms of what the LLMs can do and what LLMs we have available. So the promise of combining these two technologies is enormous, which is why we've been investing all this time and effort in doing so. Natural language interface. Humans are very good at having conversations. We do it all the time on text messages and Slack and Skype and even, I guess, via email. And we also do it in real time when we talk to our peers and everybody else. So we're very good at a conversational style interaction, and we've also got fairly good at talking to machines. Talking to Siri or the 2 others that I don't want to mention because they're sitting next to me. We've got good at talking to them and understanding what their limitations are and asking just in the right way that they are able to answer. So people have been able to adjust how they interact with these systems, and it's very comfortable. And so being able to combine that approach with your enterprise data seems like it would be a huge win if it could be done. The second thing is that if you can tie these 2 things together, we know that the LLMs are really good when you can provide a lot of context to kind of anchor them and the answers they produce. And I think the most popular mechanism for sort of exposing your own data, enterprise data, revolves around creating vector embeddings on chunks of data and being able to pull those back that are relevant to a particular question and anchor the sort of answer to the question in those fewer chunks of data that read on that question. So knowledge graphs can be used to kind of bring back just what you need, that is a win, and can greatly improve the accuracy of the data, and also start to give you a handle on things like provenance. You know, where did we generate this answer from? Which specific pieces of information? Another really big advantage is that if you can bring your data online and make it available sort of through an ad hoc sort of questioning type interface, it streamlines exploration of that data. Users can simply ask whatever question they like and see an answer, and then follow it with that answer may spurn a second question or a third question, and so on. And they can play with their data. You can give instructions to the system and have it do things to that data that you can react to. And why this is so powerful is, I guess, for the last reason on the slide, which is the enhanced and accelerated decision making. Right now, we have a lot of customers who build dashboards on top of our knowledge graphs, which they use to look at particular slices of information and filter on them. And the dashboards can be quite complicated, just like building a spreadsheet or something, or a Tableau BI dashboard or Power BI dashboard. There's a good deal.
Sean, I'm sorry. We lost your audio for about 10 seconds.
Have you got me back now?
Got you back now.
Okay, I had to disable my phone lest it ring and cut the audio. There we go. Okay, so what I was saying was that enhanced decision making, if we can allow end users to simply ask whatever they like, they can bypass the whole process that is a currently pretty expensive process of building a dashboard or writing a query to fetch the data that they need. There's only so many dashboards you can create. They tend to get more and more sophisticated because they try and cram as many possibilities and variations into a single dashboard as possible. This is an analyst who creates a dashboard for the business or for an organization. They put many controls in as they can to give the end user as many ways of slicing and dicing that information that they're seeing within the limitations of kind of the extractive data that they've put the dashboard on top of. And it's an expensive endeavor, and often those dashboards are quite complicated. If the user can ask the question and get a direct answer, and ask it again if they weren't happy with what they were seeing, and do variations on that, that's the equivalent of getting a dashboard right in this particular moment, just for the particular problem that you're trying to address. So not surprisingly, the early adopters of this technology, people who I'm working with as our first sort of customers, are all kind of operational use cases where they're doing looking at clinical trial operations, or they're looking at company financial information, or they're looking at trying to detect somewhat near to real-time compliance issues, insider trading, and so on. So these are places where there's often an investigatory element to what the activity that they want to do, and the difficulty of creating dashboards around all of that is high. So they just see this technology, if we can get it working adequately, as a way to much more quickly allow their end users to follow their noses through the data, and therefore accelerate the decision making and so on, and reduce the expense of doing this. Now, what I want to show you very briefly, first of all, is what I'm talking about. So you get an idea. I'm going to ground us in what this might look like. And what I'm going to show you is the first prototype we released in May, just very quickly as an example. So I'm going to run a video that we recorded. I'm just going to go back a teeny weeny bit. First of all, just to show you, I'm going to full screen this. Hopefully everybody can see it. This is the ontology that describes the data. So this is a fictitious data set concerning tubes and people who buy tubes and orders for tubes and the flow of tubes and the temperature of tubes, and it's all about tubes in some kind of industrial setting. So this is the relatively simplistic model that the knowledge guru, which is a client we've written, that essentially I'm going to explain how it works after this, but essentially it's a client that allows an interactive conversation with the data. So I just got to force forward to where that starts, and I'll give a little bit of commentary. We'll show a minute of this. First thing is it introduces itself. It's looked at the ontology, so it already knows what it can talk about, and that's pretty important. We don't want it to answer questions it doesn't know about. And here's Greg, one of my colleagues, asking questions, and here it's actually looking at the ontology, and it's explaining what kinds of things we've got that we can talk about. And if indeed you ask about other things, it'll tell you it can't answer them because it doesn't have that data. And here now Greg is simply asking fairly simple questions about the data, which are then turned into queries. And the queries are then executed against the knowledge graph, and the cards are selected which display the data. So far we've been seeing answer cards, where it's really just as a single answer. But the next question is going to need a different card. It's going to need a card that can render a list of results. So it's going to come back in a table. And Greg wasn't entirely happy with how that was ordered, so he's going to ask for it to be reordered. Now you're noticing, I'm sure, that we understand the context of the questions that happened earlier, because it's able to part of what's being sent up to the LLM records the earlier questions and some of the results, so that those can be referred to in the questions. It's something you really do need to create a natural conversation. And so here's now Greg asking to make a line chart of what was previously listed and so on. So hopefully that gives everybody a bit of an idea of the kind of interaction one can have, and it can get much more sophisticated than this. We've got a lot of visual widgets that we can use to display data. You can give instructions to the system to really change how things are displayed. You can add things in on the fly. But the idea is that the user is able to just ask whatever they like, and the system is essentially a colleague who knows how to run these queries. It's essentially an avatar. The knowledge guru is an avatar representing the knowledge graph. Even though when we actually write the prompts and so on, we make them initially at least completely independent of the data that's in the knowledge graph. So we want the software on the client side to essentially introspect the knowledge graph's ontology and then become a personality that is that knowledge graph. All right, I'm going to stop the video there, but hopefully it's given everybody an idea. And I'm going to go back to the slides. All right, so what we saw there was we have an ontology, which is part of the input context, the prompt, and it's passed up to the LLM along with the question, and what comes back is a graph query, and we use the Sparkle language as the query language. Sparkle, for those who don't know, is a standard language for RDF, which is a graph representation of data, often described using OWL, which is an ontology, kind of a proxy for schema. And we'll get into some discussion of why that's useful and interesting later on. But I will draw your attention immediately to the labels in the ontology. Essentially, there's a semantic layer provided by the ontology. And that semantic layer is being provided to the LLM in the context of the questions being asked, and along with a little bit of previous history of the chat. All right, so what is the guru that we've seen? What is this first go around? This is the first version of this first generation, if you like, that we built. We are starting to address some of those issues that users saw that I described earlier. I'm sorry, I'm going to try and minimize the, sorry, I'm just trying to get rid of one of the windows. It's obscuring the screen. There we go. All right, so we've addressed some of these problems. One of which is the accurate responses. We're generating queries, and the queries are against knowledge that we actually have, that we've spent some time preparing in our knowledge graph. And a hallucination would essentially be a bad query, which won't run. There's a syntax error, or it's or it simply doesn't produce any results. So we can't produce information that is, in general, it's harder to produce, much harder to produce information that is hallucinated. Now, in the early experimentations of prompts and things, we would have issues where it would try and hallucinate additional properties or predicates, hallucinate paths through the data that didn't exist, and of course, those would fail. They'd either fail in ways that we could easily detect. There would be syntax errors in the query language, or because they produced no results, we could look at them again and say, okay, something must have gone wrong here. Let's go back and re-ask this with maybe some extra help. So accurate responses, provenance, of course, because we know where the data in the knowledge graph came from, so we know where our answers are coming from. We use the ontology to bound the queries that can be generated. So the system can only ask, or can only generate, the LLM can only generate queries for which it has ontological elements, components, whether they be classes with properties on classes or object properties which connect classes. So anything outside of that is not allowed. And it's pretty scalable because an ontology is kind of universal. You can create an OWL ontology to describe pretty much any industry. And in fact, many industries do have standard ontologies, and many enterprises have ontologists on staff. Many enterprises will describe existing data using ontologies and use those as a way of sharing kind of the language of the business with different groups within their business. Another and final and pretty relevant point is that you saw that the questions Greg were asking are pretty ad hoc. He can ask whatever he likes. And because of the structure of the knowledge graph, we can answer those questions. So in other words, the queries can be that are generated can be very ad hoc queries. And that combination essentially gives us a new way of interacting with our data. So how does this work? Let's start at the top left-hand side here. We have a new question that the user, you saw a client experience was web-based. It actually was built on top of and inside our dashboarding tool, which gave it access to all the charting widgets. But we added cards for different kinds of answer types. And so there was an answer card that you saw there that was an answer with query. So essentially it was a template where the result from the query would be filled into some kind of sentence. There was another one there that you saw briefly, which was a table. So that was a query to table card. We have a query to chart card, which showed us the line chart, and so on. And so probably there's about 10 or 12 different kinds of cards that have different effects. Some of them are cards that that would provide suggestions or would solicit user input, maybe with drop-down boxes where we're trying to resolve entities, and so on. But essentially, each of these cards are used as part of service of essentially displaying the result of the query or the LLM's output to the end user. So anyway, so the user types in a question, much like you saw Greg did. We also fold in some amount of the previous results, and there's a limit to obviously how much you can do there because of context is an issue. But a certain amount of that is very useful, and there are techniques for compressing that information, so that at least when this new question is seen, it's seen in the context of the previous questions. Those things go in, as well as at the top here, you can see the ontology is also pushed in. So the ontology is a description, and all of that is sent as the request to GPT. And typically we've been using GPT-4 and a little bit of GPT 3.5 Turbo. So we're using the OpenAI APIs, either through directly to OpenAI or through Azure. We are very interested in some of the open LLMs and are looking to experiment with those. But for the moment, the training of the OpenAI model seems to have an awful lot of knowledge about Sparkle, which is necessary for making that for generating Sparkle queries, which is what we want back from the LLM. We then execute the query in our client software against the knowledge graph. Part of the response not only includes the queries, but it also contains the information about which card we're going to use to display the result, and maybe some binding instructions explaining maybe a bit of a template for how the query should be slotted, or the results of the query should be slotted into the result, which is then displayed. So the query is run against the knowledge graph, the answers packaged together, and we display the card, which the user can see. So that's roughly speaking, the flow of how it works. Now, we're getting more and more sophisticated with each sort of iteration of this, where we're starting to create things that are more like the lang chains, where you've got prompts checking prompts, where sometimes we want to reformat the answer a bit, or where we might want to validate a query was really correct, or there are a number of things that we're starting to add in to often use different prompts for different elements of maybe one card may require another call to an LLM to help it do some aspect or other. So, but the overall rough flow is this. But I would say that as time goes by, we're going to be using more and more LLM calls to create an even better end user experience. So where's the real magic here? I cannot overstate how important the fact that we've simplified the data representation using the ontology is. It's very obvious when you play around with the stuff what a difference it makes. When we start meeting ontologies in the wild that tend to be sort of bottom-up ontologies and reflective of underlying relational schema and other underlying data storage systems and data formats, you often start to see the ambiguity and the paucity of semantic explanation that that is missing from ontologies in the wild. And one of the subsystems we've been working on more recently is prompts to actually improve the ontology that the LLM sees from the original ones that are really not very or less semantic than they could be. So if you have a very descriptive ontology, it's great. If you manage to map all your data into that, it's even better. But in the real world, that's problematic. And so there's a opportunity, if you like, to improve the ontologies and even mine them for issues where there's ambiguity potentially through an ontology that you can potentially have multiple paths of travel. And different answers can emerge depending on which path your query takes. You may want to create signposts on the ontology, which kind of indicate, hey, for this kind of question, use this path through the data, and for this kind of question, use another path, and so on. So, but in that kind of work, it's very obvious how much better the LLM does when you can create a ontology that describes using human language, and one side of it, the data that the domain expert person who's talking to the system is going to be using. The ontology is a useful piece of it's a useful standard because it describes both the human readable version of the data, the semantic version of the data that an expert in the domain would understand and be able to, and by that I mean someone who's a chemist or a financial controller or someone who operates clinical trials. Those people know what their business, and the language of the ontology is reflective of that. But it's also a mapping. It's a mapping between that and the underlying unique URIs that essentially or the real name of each predicate, of each concept that you're describing in your ontology. And those predicates are what you're going to end up using in your query. So the ontology essentially is that mapping between the human readable element and the machine readable element. It's ironic that the LLMs are actually better with the machine readable element, and they like a very nicely described machine readable ontology in order to be able to then select the appropriate predicates to create the queries. And as I mentioned earlier, we use the ontology to constrain the LLM's response. So if you're asking questions outside of what the ontology describes, the prompt tells the LLM to not respond, or rather to say, hey, I don't know how to answer that question. Maybe you should add some data about X, Y, or Z, and then I could answer that. But it's going to refuse to answer questions that it doesn't have an ontology that it can map the end user's textual question down to. The output of the LLM, at least one part of the output, is the Sparkle query. And as it says here, it draws that the predicates from the ontology supplied in the prompt. And then the magic of knowledge graphs is that ad hoc queries are really exactly what they're built for, and what we built the system for. You know, the ANZO system underneath all this is a system we built to describe data, how in the way that end users think about it, and to allow them to ask any shape of query against that data. So we don't think about too much about the questions that humans are going to ask of data or the dashboards they're going to build. Instead, we focus on getting a good representation of or description of the data we have, and connecting it all up into a comprehensive graph, and then giving it over to the user and saying, okay, we've basically put all that data into a form that describes it how you think about it. Now ask whatever you like. This is a very different approach to traditional data integration, where you tend to think very much about the questions you're going to need to address first and make sure you have A, got that data, and B, you've put it into a schema that will allow you to create say a SQL query that would be able to access that data. The knowledge graph approach to data integration turns that completely on its head. And it doesn't care what questions you have, provided you've got the data well described and connected up into the graph. So a little bit about SQL versus Sparkle, because you know, it's pretty obvious that most of the data that's in structured databases is accessible by SQL. So why Sparkle? Well, one obvious reason is because that's what we've been building on, and that's what our knowledge graphs are on. So that's where I started. But of course, I'm always looking with a back over my shoulder at what's going on in the SQL community, and there's quite a lot of literature on that. There's something called the Spider benchmark, which is a benchmark where people are trying to get a whole battery of sort of sample relational databases answering accurately or generating SQL queries for them. And you can go and look at that literature and see, and they're getting quite far. But what inherently, it's a kind of a limited approach, and I'm going to discuss a few of those limitations now, and why I think we're just so much further ahead using a Sparkle or some other kind of graph-oriented language that works well with a semantic layer. The first thing is to do with schema. Now, relational schema are, first of all, it's very hard to discern if you just look at the schema raw. What is multiple models, if you like, or layers of models are intermingled within the schema. So you've got a physical model, you've got the logical conceptual model, and finally you've got a sort of an external model. But all of those are just together in the schema, making it pretty hard to unpick what's what if you're a naive LLM coming to the job. And it just simply gets in the way. It impedes understanding of what is meant by this data. The relational data is built for highly efficient storage and retrieval using kind of known paths through the data, paths that were planned through the data. And that tends to be the sweet spot. And so language models have a hard time trying to understand that data. And when they do work, it tends to be more like an analyst generating SQL as opposed to an end user. Some analysts who kind of can ask questions in the right way. The mapping of the business level domain end user semantics onto that, there's a significant gap. And I think that Sparkle and an ontology really start further and closer to the end user, which gives them a very big advantage. So in the ontology, we try to represent the data at the conceptual level, at the user's level. And we're using human readable labels and descriptions, quite often not something you see in the table names and column names of relational databases. So the whole semantic layer is natural to a knowledge graph that is based on the semantic standards from the W3C. They already have this notion of describing data at the human level, in languages with labels in as many languages as the solution wants to support. And so the business user is often involved in the creation of the knowledge graph, is already thinking and using the same sort of vocabulary or close words and language to that of the ontology, if you've done the ontology well. So this is a whole layer that I think people will struggle with a relational database, and you'll have to artificially insert semantics in some way that isn't standard. Unlike the ontology, also you've got this problem of untangling these different models that are all represented together, and simply you saw I pointed out on purpose, you saw the ontology I showed you at the beginning with hundreds of entity types. Can you imagine trying to represent that in a relational database? And yet that is the reality of the complexity of the domains of information that many of our customers are addressing. You know, if for every entity type you need at least one table, and then for any property of that entity that is multi-valued, you need a subtable with a key and so on. So you can see how the complexity of building up the joins and so on, I think I'm kind of getting ahead of myself, the complexity of building up those queries is much, much higher. So the LLM has to get more and more right. And the thing about queries is either they're right or they're wrong. I mean, either they work or they fail because they have a syntax error or because they found no results. So there's no leeway really for error here, and so making it more and more difficult to generate whatever your target language is, query language is very problematic. So if you have the fixed structure, tables and columns and relationships, I always think when I work with knowledge graphs that it's kind of ironic that relational databases are called relational databases when they're really so poor at representing relationships. They're very bad at ad hoc queries. You may end up generating queries if it's even a correct query, you may end up generating queries that are just suboptimal from a point of view of performance. They may not be indexes in the right place and so on. So all of that is a whole class of problem that we don't have when we use a graph language like Sparkle. Sparkle is far more fluid, and the questions almost turn into queries that you can read, which I'll show you a little bit about in the middle in a minute. And the other thing, of course, is, as I mentioned earlier, ad hoc queries are just not a problem. We never organize the data around particular questions or particular queries when we build a knowledge graph. We concentrate on representing the data truly and well described, and then we expect the user to be able to ask any question or any query that they like and it to perform reasonably, and that's the design point of the system. So the queries themselves end up being simpler, which means that you can ask more complicated queries. You can ask more complicated questions because it was simpler to construct them. And it just gets exponentially harder when you're trying to do that in SQL. And really all of these are kind of variations around the same theme. But the representation, I kind of mentioned this earlier, if you were trying to represent the ontology you saw at the beginning in a relational schema, you can imagine the hundreds and hundreds of tables you would need and the resulting complexity of the SQL you would need to write to sort of traverse that data. With an ontology, an ODSC ontology, you're directly representing the data model at the conceptual level, already. So you don't have that indirect level of complexity. As I mentioned, I'm going to show you, complex queries align directly with natural language, making them simpler and more accurate to construct. And so we've got pretty far with this approach. So I'm going to use a little illustration here just to kind of explain that last point again. So here's the card that the human is putting an answer into, sorry, a question into. And then here is what's going on underneath. This is the ontology. On one side, we've got the human readable labels. So there's a class and some properties. And these are the underlying, on this side, you can see the predicates, the unique identities of each concept described by these labels. And you can see how this question is almost readable in SQL. Right? You can almost read what is going to happen. And so when it's executed, you're going to get back a result, a table in this case, listing that information. And so this is actually an actual example. I may have simplified it slightly, but this is an example, and you can get the idea of just how much easier it is if the data is represented in at least one way of representing the data is in kind of human language at that level. So we've been running this prototype, starting to run it with our customer data and improving it. And what comes next? What are the problems we're seeing? What are the things we're going to have to address? And how do we what's the next generation of this system going to look like? And so these are some of the challenges that have become obvious now that we're sort of got past the basic ones, the first order ones of provenance and being able to generate queries reasonably accurately, and now it's more about getting that experience right so that the user feels like this is a system they want to interact with, as opposed to one that's just a pain in the ass to use. These are examples of how you've got to get a system like this, a conversational system, up to the level at which the user is going to be interacting with their colleague avatar, as opposed to feeling like this is a very frustrating experience. So one problem we saw fairly immediately was the problem of entity resolution. So if the system keeps asking you every time, not just once and learning, but asks every time, did you mean Germany the country? When the context makes it plain that we did mean Germany the country, at that level, if you didn't get that right, the user is going to get pretty fed up with the thing very quickly, having to constantly repeat answers that they think the system should, or if it had been a human on the other end, would have known by now. So that's how do you keep conversation fluid? One of the wonderful things about the interaction with the LLMs is there is a certain tolerance for error and misunderstanding. We do it all the time when we talk to people and we get a response back and it isn't quite what they either misheard us or they misunderstood us or we didn't explain correctly. We're used to constantly sort of mediating our conversations. So there is a level of tolerance, particularly if there isn't a complete breakdown, like the card doesn't render or the LLM forgets to talk, the JSON protocol and things just break, we can't parse it. Once you get beyond that level, there's a reasonable tolerance for errors, but it only will take you so far. But it does get us quite a bit further than you get with, say, when you build a dashboard, which just has to be 100% correct. And users will guide the system to what they want, provided you can provide that level where it doesn't frustrate them too much. Another problem is where the answers are kind of monosyllabic. Nobody likes to talk to a passive-aggressive person or avatar. Did the production figures increase? Yes, they did. I want to know more than that. I'm asking in a kind of, it's an open question, so I want an answer that is has more in it. So how do we get the system to provide more? in a comfortable way, and at the same time not provide too much more, provide just the right level. Sometimes you ask people a question and they'll tell you every single detail they think you need to know about it, and that also is painful. So how do you kind of help the system to find that balance, which may be different for different users and for different questions? So these are various problems that we're working on. Query and data handling. So these are kind of mechanical things, but if the LLM doesn't know about the reference data in your database, many of the ways we describe information today, the application has a list of things like what status codes mean, or what entities, how the labels for all the various entities in the system. These are things that the application already knows how to do, drop down lists to stop you having to type something in. The applications tend to assist, but when you're dealing with a knowledge graph where all of that is simply exposed, how do you make sure that the questions, the queries that are generated have the appropriate filtered string values and so on? Or what happens if somebody asks a reference to something that is ambiguous, like VW? May mean, the database may have Volkswagen, but do they mean Volkswagen as a company? Do they mean Volkswagen as a model, make of car? All of this may make increasing amounts of difference depending on the application that you're trying to make. So effective entity resolution. Integrating feedback, I think, is extremely important, where you can start to improve the overall experience, because for a single knowledge graph or solution using a knowledge graph, it's going to be used more or less in the same way over time. So as you learn how people ask questions, what kind of questions they ask, and what kind of responses they like, those need to be fed back in. And increasingly, we're looking to fine-tuning to help us improve greatly the overall experience of these systems in that respect. Now, the final one is kind of pretty interesting, because for many years we thought, hey, if we can just describe all our data using ontology and it's in the language of the user, that's going to be enough. But we weren't really expecting a user that wasn't a domain expert. And the LLMs are not a domain expert. You can potentially help to start to make them a bit of a domain expert through their through fine-tuning and through prompting, but often there's a sort of a gap between a well-described knowledge graph, as good as we could do it today, and a user asking a question that has all sorts of implied assumptions about how they want the query to be made that will answer that question. And so there's additional knowledge that needs to be captured in the solution to make this a smooth flowing conversation. And this is kind of a new area for us. And we're starting to experiment with domain specific prompt areas that augment the sort of generic prompts. We're beginning to experiment with user feedback, pulling in documentation describing the data, but often there's nuance in the interpretation of how, if you ask how a clinical trial is happening in a particular place, what do you mean by that? And what are the properties that have to be searched on to actually give a meaningful answer, and how are the results best interpreted? So all of those are areas that we're looking to enhance in the next versions of our system. All right, I'm going to stop there with just 10 minutes on the clock left and see if there are any questions. I'll just add one thing. There's a book, a free O'Reilly booklet. It's a pretty short one describing knowledge graphs and how to get started with knowledge graphs for those who don't know, and it's free. You can download it. But it's something I wrote a year or two ago, which with Dean Alleman, who's Mr. Ontology, Mr. Al, and it basically describes as best we can how you get started putting together a knowledge graph strategy for business. Anyway, with that, let's see. Do we have any questions?